For starters, I just want to go over really quick. When you add or subtract, they have to be equal size. So this could have been added or subtracted as well. To be multiplied, we just have to check these two. They don't have to be equal size. It just has to be these two things are equal. All right, to multiply, we're going to start by looking at the elements in the row. And we're going to multiply that by the elements in the column. So first row times first column. So we're going to take the first number in the first row and multiply it by the first number in the first column. So that's negative 2 times a negative 8. Negative 2 times a negative 8. And then we're going to add the next element in the row times the next element in this column. So negative 3 times 5. So it's plus negative 3 times 5. Now I finish this row times this multiplied by this column. And all we're going to do is we're going to shift over to the next column. Whenever I switch columns, I stop adding and I just leave a space. So next, multiply by next column, I leave a space and go on to that next one. So we're going to do the same thing. We're going to do that first element, which is negative 2. That's still highlighting. Negative 2 times that first element in that second column, which is negative 3. And then we're going to add the negative 3 times 2. And then we're done with our first row. Because now we're going to move to our next row, which is a 5 and an 8. So with that 5 and 8, we're going to do the exact same steps. We're going to multiply 5 and 8 by that 8 and negative 2. So we're going to do 5 times negative 8 plus 8 times 5. Then we're going to leave a space and do 5 times negative 3 and an 8 times 2. If you're here yesterday, I told you that shortcut to make sure you don't make any stupid mistakes and to quicken up the pace is these negative 8 and 5 and negative 3 and 2 we can just drop those guys down. So we can drop this down and we'll have a negative 8 here. We'll have a 5 here. We'll have a negative 3 here. We will have a 2 here. Above, we multiplied by negative 2 and negative 3, negative 2, negative 3, negative 2, negative 3. So down here, we're just going to move down a row. It'll be 5, 8, and 5, 8. So we're just going to put a 5, and an 8, and a plus sign, and a 5, and an 8, and a plus sign. I'm just going to double check that that trick worked. I have 5 times negative 8, 8 times 5. Yep, 5 times negative 8, 8 times 5. I should also have 5 times negative 3 and 8 times 2. 5 times negative 3, 8 times 2. Yeah, everything checked out. Now we just do the math. And we should come up with 1, 0, 0, 1, which is also the identity. So it's an identity matrix. That reminds me too, on Friday we have a test, right? I'm actually going to have strictly 2 sections. We're going to have a non-calculator section, but you can use a 4-function calculator on the non-calculator, and we're going to have a calculator section. I'm just looking around, looking at homeworks and stuff. I've noticed a lot of people do a lot of this in their head, and I'm going to have a hard time figuring out if you did it in your calculator or if you did it in your head, okay? So we're just going to have a section that has no calculator. That just means 4-function. It won't be super long. It'll just be basically, do you know how to do the product? Do you know how to add? Do you know how to subtract? Can you solve one by hand? And then we'll get into the calculator portion. Okay? And I know we have shorter class periods, so the test will be shorter as well. Friday. Yeah. Yes? Well, then you can't take it Friday. Glad you announced that in class. Okay, so if you're not here Friday, obviously you're going to take it Monday. Seniors, make sure you try really hard on this test. This is the last test that you'll take in math class. So it's your last chance to bring up your score. Everyone else, you should score well on this test. All right, it shouldn't be a super hard test. Everyone in our lessons is pretty short. This lesson is going to take me like maybe 10 minutes to get through. So we should, as long as we study, this shouldn't be a hard test. It should be an easy one to bring up any scores that may have suffered based upon that last test. Okay, so that's the identity. And that brings us to a new bit of information. It's called an inverse. And that is our next section, inverses of matrices. That is odd. That line down there is not on mine. Okay, so the product of a matrix and its inverse is the identity function. So if you multiply a matrix by another matrix and it comes up with an identity, it is most likely your inverse. There's one caveat to that. It has to be commutative. So that means if I take something and multiply it by its inverse, it has to come out the exact same thing as if I take the inverse and multiply it by the regular matrix. And either direction has to be the identity matrix. So we don't know for sure that these are inverses of each other. The only way I'd know for sure that they're inverses of each other is if I'd flip this and multiply on this side, and it would still come out as the identity. There are times where one direction is the identity and the other direction is not. So you have to check both directions. So in order to be the inverse, you have to check to make sure A times the inverse equals the identity. And you have to check to make sure A inverse times A is also the identity. So you have to do two separate multiplications. Because remember, with most matrices, multiplication is not commutative. What we did yesterday, we multiplied one that was A times B, and then we multiplied it by B times A, it came out to a completely different matrix. All right, in this case, they both have to come out to the identity in order for them to be inverses. So that's why in this one, when I'm going to determine whether these two things are inverses of each other, I'm going to do two tests. My first test is going to be, I'm going to check that A times A inverse equals the identity. And I'm also going to check that A inverse times A equals the identity. What was that, Alec? Did you have a question? No. Oh, okay. All right. So we're assuming these are inverses of each other. That's why I asked. So like I said, the first one we're going to do is we're going to do 3, 4. Ooh, that's not enough space. I'm going to do 3, 4, 5, 7. I'm going to multiply that by that 7, negative 4, negative 5, 3. I'm going to check to see if that equals the identity. On the other side, we're going to flip it. And we're going to do 7, negative 4, negative 5, 3. And we're going to multiply that by that 3, 4, 5, 7. The first thing I'm going to do, I know it's kind of redundant because they're the same size, but I'm just going to check to make sure I can multiply. And that's by writing out the two matrices, making sure that's equal, so I can do the multiplication. Same thing over here, we'd have a 2 by 2. 3, 4, 5, 6 is a 2 by 2. 2 equals 2, so I can do the multiplication on that one too. You are going to actually do this multiplication. All right, you are going to check by hand that these two things equal the identity matrix. I will be putting the answer up along with you, but you should be just looking down the whole time. If you're one of the people that do this in your head, I would refrain from doing that on a test. Just on the off chance you do some bad arithmetic and you have the wrong answer down here and I have no idea what you did, you lose all the points versus someone that showed some of the steps and I could see what they did. Yeah?
So to find the inverse, you would like switch these two and then make the other two negative?
Could you say that again?
Okay. So to find like the inverse, so the inverse of 3, 4, 5, and 7, you'd switch the 3 and 7.
Okay.
And then you'd make negative 5, or make the 5 and 4 negative, and that's like true for everything.
But you're going to divide also by the determinant, and we'll get to that.
Okay.
Oh, you're just looking at, yeah. So it follows that pattern. We have to do one more thing. It just happens that the determinant in this one is 1.
Okay.
That'll be the next thing we do is showing how to get that. Yeah. Yeah. You don't have to know how to do that yet, but it's a good pattern recognition because you will be doing something just like that. We can also use our calculator to find our inverse. So let's go ahead and take out our calculators. Oh, scratch that. Hold on to you. Have them out. But we're going to do it in the next one. We're not going to do it right now. We're going to do it on the next one. Okay, so just like Peyton said, we're probably going to have to come up with our own inverses. We're going to have to come up with our own inverses. We're only going to do 2 by 2s. Anything bigger, we're going to let our calculator handle that. But 2 by 2s are really easy to do by hand. So if I want to find the inverse of the matrix, and we're going to call it our matrix A, B, C, D, the inverse is, just like Peyton said, we switch these two. So we have our B and A switched. We change the signs of B and C. But we have to divide by something called the determinant. And the determinant is just our corners multiplied minus our other two corners multiplied. All right, so we switch A and B, so that tells me I'm going to multiply A and D, so we're going to multiply A and D. We switch the signs of C and B, that's why we subtract B and C. I want you to note really quick that D cannot equal 0. If D equals 0, the matrix has no inverse. If it's on your calculator, it'll come up with some error. If you try to find the inverse, it'll say error, cannot do it. Do something else. So there are matrices that have no inverses out there. And if your D is ever 0, that is one of them that cannot be an inverse. All right, the steps to finding an inverse. Peyton walked us through most of them. She said switch these two. Do the opposites of C and B, and then do them all over D. It just happened to be the D and the other one was 1. All right, so we're going to do all of those steps on this 3, 5, 5, and 9. So the first thing we need to do is find our determinant. So we're going to find our D. And remember, D is A times D minus B times C. Where our A value here is 3, our D is 9. And we're going to subtract 5 times 5. Well, 3 times 9 is 27. 5 times 5 is 25. So our determinant is going to be 2. So we have our determinant of 2. Then I'm going to go step by step. So our step 1. Step 1 is to switch our A and D. So that's just going to look like 9 up here, a 3 down there. Step 2 is to change our signs. So that means we're going to do the opposites of those directions. So we still have that 9, we got that 3, we're going to do negative 5 and negative 5. All right, so I just switched the signs. So these switch places, these switch signs. Our last step is just divide everything by D. So step 3 is just put everything over that D. And so that's going to be 9 Oof, that's tiny. That's too tiny. I need to make this bigger. That is going to be 9 divided by 2. Negative 5 divided by 2. Negative 5 divided by 2. 3 divided by 2. And we now have the inverse. All right, for the second one, we're going to do the exact same thing. We always find our determinant first because something's going to happen on this determinant. Our determinant is going to be 1 times 3 minus negative 3 times a negative 1. That is A and D times B times C. Well, that's just 3. Negative times a negative is a positive, so it's 3 minus 3, which equals 0. So in this case, there's no inverse. And we are done with that problem. So make sure you're fully aware that if D equals 0, you don't have to do any more work. Okay? If you didn't know that, you might still try to do work in here, and it'll be a waste of time. So the big two things that you need to recognize for today is that if I ask you if two things are inverses, you have to go both directions. And if you're calculating a determinant, if it turns out to be 0, there are no inverses. Don't get those two problems wrong just because you're too lazy to make a note in your notes and study that. All right? And I don't know how many times I've told you that people are going to get these wrong and you still get it wrong. And then I check your notes when you ask me, and nothing's written in your notes. All right? So you have yourself to blame if you didn't write down that you need to know this. Okay, real quick. If we look at 1 and 3, notice it says make sure that A times I equals A, and I times A equals A as well. I is the identity. It's not the inverse. Inverse is A to the negative 1. So they're just saying, hey, check to make sure if you have A times... So do that multiplication and make sure it comes out as 1, 3, 4, 5. Whether you do it in your head, this can be done in your head because it's 1 times 1 plus 3 times 0. Well, that's 0, so you're just left with 1. So this can be done in your head. Also, like I said, you can do these in your calculator. So what I want you to do right now, and I'm just going to assume that you're doing it, and you're going to have questions if you want, go ahead and find the inverse of 3, 5, 5, 9 in your calculator. That's using that matrix button. Edit your matrix. Quit. Go to your home screen. Then go to your matrix things, enter A like you have been doing, like when we did the multiplication, A times B. And just hit A. And then use that inverse button, that x to the negative 1. The same button you used to get the matrix, but instead of hitting second, you're just going to hit that x to the negative 1 power, and it should come out to this. Let me know if you can't get it or something's not working in your calculator.